At the Center for Wireless Information Systems and Computational Architectures at Arizona State University, we've been developing the concept of fluid protocols. Our goal is to develop an advanced architecture for software-defined radios. To do this, we're going to create tools to improve protocol development. We're going to develop tools to aid the implementation of the protocols on processors. We will execute on heterogeneous processors these fluid protocols. And we will demonstrate in an over-the-air system the fluid protocols, including the ability to change the protocol as the environment changes. If one imagines how protocols are typically developed today, and by protocol I include waveform design, there is a particular environment for which the protocol is designed. Of course, in real life, the environments change significantly, and as the problem of the user changes, the needs of the user change significantly. And current protocols do not necessarily keep up with those changes. In the figure you see, the link length, data rate, latency, delay spread, Doppler spread, all move depending on the environment, and the user distribution and potentially the spectral allocations may also change. As a result, a system that is appropriate for one set of characteristics may not be appropriate for another set of characteristics. In our protocol development toolchain, we first specify the environment in which the protocol needs to operate. Based on that information, the protocol recommendation engine develops a set of recommendations for parameters for our fluid protocol. We can simulate the protocol that is specified by the protocol recommendation engine. Then we have a hardware recommendation engine which takes those parameters and develops an efficient implementation given a heterogeneous processor system. We have a surrogate processor that we use, which has a set of scalar processors, vector processors, and application-specific kernels. We will now demonstrate a preliminary version of the processing chain, where we go all the way from environmental specification, through the recommendation engine, through simulation, through the hardware recommendation, and an implementation where we send a signal over the air. We will then modify the environments and the specifications for a protocol, and go through the process again. Here we see the working version of our GUI, which acts as an interface to the hardware recommendation engine. So we started off by saying that we were thinking about a rural environment. We're going to think about a problem in which we have a 500 kilobit per second data rate. One might imagine this is useful for low quality video or high quality audio. We will specify the chip rate. In the future, we'll have a more sophisticated interface for developing and using the recommendation engine. The protocol recommendation engine provides a set of modulation schemes. Here we're specifying the medium access and the duplexing for the communication system. Because the link had very little delay spread, it recommended a single carrier system. We can now start the simulation. The output of the simulation, you see a laydown of the nodes and also a time domain plot of the sequence of the frames. As outputs of the simulation provide a number of plots that will allow us to inspect what's going on, which include the bit error, the constellation plots, the spectral plots for both at the transmitter and the receiver. So we can go back once again using the recommendation engine, and now we can execute the hardware recommendation engine. Hardware recommendation engine determines how to take the protocol which is developed and translate that into an executable which runs across the heterogeneous processor. We then install on the processor communication protocol, and we can see here that the installed protocol is successfully working on the radios, and signals are being transmitted over the air. Let's go back and consider another scenario. Here we think about an urban environment specify a distance of 400 meters. We want a much higher data rate, so we will consider 3 megabits per second. We up our chip rate correspondingly, given the higher data rate. The recommendation engine makes recommendations. Once again, we consider an FDMA protocol or medium access. We simulate this higher data rate protocol. We look at the figures that are produced. Once again, we see the receive spectrum, the transmit spectrum. Go through the process of selecting the particular set of parameters we would like to build. We then go through and have a hardware recommendation engine, develop an implementation. The implementation is then installed on the radios, and the radios once again use this new protocol to communicate signals over the air. We have discussed and demonstrated the results of our preliminary research in fluid protocol development. And in real time, we have gone from an environmental specification through simulation, through how to implement the protocol on hardware, to implementation and over-the-air demonstration. On behalf of the many individuals at ASU who spent long hours developing this rather sophisticated system, going all the way from the GUI allows us to specify the parameters for the protocol, through the recommendation engine, through the simulation package, through the hardware recommendation, and through actually implementing the system on real over-the-air radios. We thank you for taking the time to view this video.